Hello to everyone, Robert Wohlfahrt here, and today I want to show you how to implement public key authentication for SSH. Yeah, if you connect to a remote system via SSH, then you typically have two choices for the authentication. The first one is to use a simple password authentication. Yeah, you enter your password and you're on the system. Yeah, and the second one is you use a public key authentication. And there are two main reasons for choosing the public key authentication over the password authentication. First is user passwords aren't often as complex as they should be. They are often guessable. Yeah, so you can secure the authentication part of your SSH connection by simply using the public key authentication. Yeah, that makes the authentication part of your SSH session much more secure. The second reason to choose public key authentication is if you want to do some automations. If you want to, for instance, copy files, if you want to do some backups from one system to a second one, and you want to do this automatically, or once a day, once an hour, you simply cannot type in every time your password for login. Yeah, if you want to copy via SCP, via rsync a file to a remote system, yeah, then you need to implement a public key authentication for your SSH. Yeah, it is lesson, I want to show you how the public key authentication works and how you can implement it. Yeah, it can be a little bit confusing if you do it the first time, but if you have done it one time, you can repeat it once again. Yeah, it is really that easy. Yeah, so let me show you how this works, how to implement this by simply starting my screen sharing. So here we are. I have prepared two systems. Here, this is in the first console. This is the, let's say, the local system. This is the system I want to connect from. And I want to connect to this system. This demo system is the remote system. Yeah, this is the remote system I want to connect to. And if I want to connect to this remote system, yeah, I need to know the IP address or a resolvable host name. So let's take an IP address of the system. This is this address. This is the IP address here. And let's connect to this remote system via SSH. And now the IP address. Yeah, great. And I'm asked for the password of the remote user Robert. I'm asked for the password of the user Robert. Let's type in the password. I'm asked for the password of the user Robert because the SSH client tries to authenticate me as the same user as I am on the local system. So if I'm local logged in as the user Robert, then the SSH client tries to authenticate me as the user Robert on the other system too. Yeah, so I'm here now connected to the demo system via SSH, and I'm connected as the user Robert. Let's leave the session and let's try to build up a session as a different user. Yeah, if you want to connect as a different user to the other system, then you can simply use this pattern. Yeah, simply write SSH, then username and then the IP address. Yeah, in this example now, the SSH client asks for the password of user Max on the remote system. Yeah, there isn't a user Max, this won't work. Yeah, but this is a way if you want to, for instance, connect as the root user. Yeah, and you can, if you want to, use another syntax option, -l for login, and then the username. Yeah, it's again the same. Yeah, say to the SSH client you want to connect as another user to the remote system. Yeah, so this is simply the way it works if you want to connect via SSH to a remote system. And I think you have done this many times before and you already know this. Yeah. Now let's implement a public key authentication. I don't want to type in the user password. I want to do a public key authentication. Yeah. So how can we do this? To explain how this works, I have prepared some sort of whiteboard for you. Here it is. Here is the whiteboard, simple Google presentation sheet. And yeah, here we have the local system. On the other side, we have the remote system, and we want to connect via SSH from one system to another one. And we want to implement public key authentication. If you want to use public key authentication, yeah, we need a public key. We need a public key. So key pub, this is my public key. And if we have a public key, we always have a private key too. We always have a private key too, because a public key is always one part of a key pair. So if you need a public key, you need to create a key pair. And one part of this key pair is the public key. The other part is the private key. Yeah. And as the name says, the private key is the key that should be private every time. Yeah. And the public key is the key you can distribute to the world. Yeah. So we need to create such a key pair, a private key and a public key. And if you want to use this, public key for authentication, then you need to transfer this public key to the other side, and you need to store it there, accessible for the target user. Yeah, you want to connect from this user Robert to this user Robert over there. Then this local user Robert needs access to the private key, and this remote user Robert needs access to the public key on his system. Yeah, we need to transfer it. So, and then if we connect to the remote system, yeah, if we build up an SSH connection, then the remote system tries to prove that we have access to the private key. Yeah, and if we can prove that we have access to the private key, then we are authenticated. So how does this work? Yeah, simply you need to know that this private public key pair is part of an asynchronous encryption standard. Yeah, RSA, for instance. And asynchronous encryption means if you encrypt your data with one part of a key pair, then you need the other part for the decryption. Yeah, every time. So if we encrypt via private key, we need the public key for decryption. And if we encrypt with public key, then we need a private key for decryption. And the remote system uses this to prove that we know the private key. So the remote system simply chooses a random number, a random string, yeah, a random key, some random value. Yeah. So, and the remote system encrypts this random value with the public key. And then it sends this back. This encrypted random value will be sent back to our system as a challenge. This is the challenge. The system asks now, please decrypt. Please decrypt the challenge. You know the private key. Prove that you know the private key. Prove that you can decrypt the challenge. Yeah. If we know the challenge, the private key, then we can simply decrypt and we send the decrypted value back. Yeah. So remote system takes the public key for encryption of the random value. This challenge is then sent to our local system. Our local system has access to the private key, hopefully, and it can decrypt this challenge. Then it sends it back, and it sends back the random value. The remote system verifies that the random value we sent back is the random value he chooses, and then it is validated, it is proved that we have the private key and we are authenticated. Yeah, this is the way from a very, very high view how this public key authentication works. Yeah, now let's implement this. How can we implement this? Yeah, we need a private key, public key pair. We need to generate this. How can we do this? We simply take a tool from the SSH suite. This is always installed. SSH keygain is the name. And this SSH keygain can be called with a number of command line options to modify the behavior, what type of key pair is created, how's the size of the keys, and so on, where are the keys stored. So let's, for simplicity, always or nearly always call SSH keygain without any additional parameter. Yeah, then it chooses a default type of key pair. Then it chooses a default key length, for instance, and then it takes a default place where to store this key pair. Yeah, and this key pair will be stored within the home directory of the local user. Yeah, if you are here, user Robert, then within the home directory of the user Robert, .ssh directory is available or will be created. Yeah, and then we have a key ID underline RSA if we have an RSA key. Yeah, and this is the private key. And then for this private key will be a public key stored. Yeah, so this is the private key, this is the public key, and the content of this file needs to be transferred to the remote side. Yeah, the remote side now needs a file within the home directory of this user Robert here, a directory .ssh, and then a file authorized keys. Yeah. At first, authorized keys is simply a copy of your public key file, but later on, authorized keys, you see, you have the S. Yeah, you can have multiple keys within this file. This file contains line-wise multiple, or can contain line-wise multiple public keys from multiple different users, multiple different locations, systems from where you want to connect to the system. Okay, so we need somehow transfer this public key there to authorized keys. So ID RSR in this example is the private key, and you need to secure this key. Yeah, everyone who has access to this key can connect to the remote system. Yeah, so if this key is stolen, you have a real big problem here. So you need to secure this private key as much as you can. Yeah, if you want to really secure the key, then you will encrypt it. You will encrypt it with its own passphrase. Yeah, this isn't the best way for using with automations. Yeah, but for securing the authentication part of the SSH session as much as possible. Yeah, therefore it is the best option to encrypt this private key via passphrase. So let's implement this at the console. Yeah, let's close the whiteboard here and let's implement this at the console. Here on the system, on the local system, let's create a key pair. SSH key gain generates a key pair. Yeah? It asks where to store the key. Please take the default if possible. Yeah? Take the default if possible. Why? Back to the whiteboard. If you take the default here, then the SSH client, if you connect to the remote system, will find this key and use this key for authentication. If you take, or if you choose to store the file on a different location, then you need to say this location to tell the SSH client tool where your identity is stored. Yeah, so you would call your SSH client every time, then with the -lowercase and the path to your key file. Yeah, if you want to make it as simple as possible, yeah, leave the defaults here for the storing location. Yeah. Okay. Back at the console. Here we are. Let's close the whiteboard and create a key pair. And let's first create a key pair without a passphrase, just to demonstrate that we can later connect to a remote system without entering a password. Yeah, let's generate a key pair without a passphrase. Just hit enter, enter the same passphrase again. Okay, again, hit enter. And now we have two files. We have two files within a directory .ssh we have ID _ RSA and ID _ RSA.pub. This is the private key. You see here the permissions. Only the owner has read or write permissions to this file. And then we have the public key, and the public key has read permissions for everyone. Yeah. Okay. So now we need the content of this public key file transferred to the remote system. How can we do this? Well, simply here via copy and paste. Yeah, let's cat the ID RSA.pub and let's copy the content of the file and paste it here. Let's create the directory .ssh. Let's create within the directory .sh a directory authorized keys, and let's simply paste the key into this file. Yeah, let's save it. We need to prove that, or we need to take care that the public key is one single line within this file. Yeah, if you take copy and paste for transferring the data, then perhaps your editor could split your key onto multiple lines. We see here that we have the cursor is there at the end of the last line here. We see in the status line we are still within the first line, yeah, on position character 402. Yeah, it means we have one single line for the public key. If you append a second key, then you have a second line, the third key is the third line, and so on. Yeah. On the console, you can prove this, for instance, via the wc command, wc word count -l. Please count the lines, and you see authorized keys contains only one single line. Yeah. By the way, if you don't know it, if you need more, or if you want to know more about such tools, yeah, simply go to shelltoolbox.com and get your copy of the Shell Scripters Toolbox. Yeah, this is a ebook, a PDF I created to give you a lot of these command line tools with sample calls, simply for working at the console, for writing shell scripts, shelltoolbox.com. Get your free copy of the Shell Scripters Toolbox there, shelltoolbox.com. By the way, we are here during the implementation of private key authentication. We have created the private key. We have transferred, copy and paste the private key into this file. And now we want to test it. We want to test it out. Let's connect to the remote system. And now if we connect to the remote system, then the public key should be used for authentication. But we are asking for a password. Why? That's because we need to take care about the file permissions for this authorized key files. This authorized keys file needs permissions set in a way that only the owner of the file can change the file. So let's have a look. ls-l.ssh authorized keys is writable here by the owning group. We need to remove this flag change mod 600, for instance, and then we have per default write access again for the .ssh directory. Let's do a change mod. Let's do a change mod 700 for the SSH directory itself. So, and now let's try it again. Voila, it works. Now we are connected to the remote system without typing in a password. By just using this RSR public key. But keep in mind that this RSR public key needs this private key, and this private key needs to be secure. If your system is stolen, you need to remove from every other system from the authorized keys the public key, so that no one can connect to the remote system if he has access to the private key. And here on the system, ls-l.ssh, I am only Robert. I'm the user Robert. I'm not root here. So perhaps I cannot be sure that someone other on the system, root for instance, gets access to this ID RSR private key. So best way now for securing the system is, for securing the key is to generate a key that is encrypted with a passphrase. Let's try this out. The way with a not encrypted password is the way you can use for creating a backup automatically, for instance. Now, if I now, for instance, use SCP for copying, let's say, etc passvd to this system, to the TMP directory, then I don't need to enter a password, and I can implement this SCP call as a cron job, for instance, to do this copy once a day, once an hour, and so on. But if I use the public key authentication not for automations, but for real logins to a remote system, then you should think about encrypting the private key. Let's do this. Let's remove the .ssh directory on the remote system. Let's remove on the local system my key pair files. And now let's create another key pair, SSH key gain, but this time enter a passphrase. Now I enter a passphrase for the key pair, test 1, 2, 3. test 1, 2, 3. This is the passphrase. And now this file, this private key file is encrypted with the passphrase. If someone gets access to this private key, then he still needs the passphrase to use this private key. And now every time I connect to a remote system, here, for instance, using this key pair, yeah, I need access to the passphrase too. Yeah, but let's first copy the key pair to the other side. And there is a really convenient way to copy the key pair to the remote side. Yeah. In the last example, I used copy and paste. I used copy and paste to copy the file to the other side, but there is a tool. There is a tool that is called SSH-copy ID. SSH copy ID, if called this way, takes your default identities from .ssh within your home directory, yeah, all these identities, and it takes all the public keys and transfers the public keys to the authorized keys file of the remote system. Yeah. And for transferring, we need a normal SSH connection in place. So we need now type in the password. We need to authenticate with the password. I authenticated with the password. Now on this system here, we have .ssh authorized keys as a file with a copy of the public key that belongs to the encrypted private key. We see the permissions are set the right way. Nobody else but the owner has access to this file. And now it works. Now it works. If I now connect to the remote system, via SSH, then this public key is used for authentication. I'm asked for the passphrase to decrypt the private key, and then I am connected to the remote side. Yeah. Okay. The passphrase I type in here will never be transferred to the other side. This passphrase is only used local to decrypt the private key. Yeah. We cannot use this for authentication, yeah, or for automation, sorry, because we cannot type in every time we want to copy a file. We cannot type in a passphrase for the key. Yeah. Every time I use the connection, I need again to type in the passphrase, but I can make it for me a little bit more or much more convenient to use the encrypted private key by using an SSH agent. An SSH agent is a tool that runs in the background as a process. And this tool can be called multiple ways. Yeah, have a look into the manual page of SSH agent. Now I call the SSH agent in a way that I say to this command, please start a bash. Please start a bash. And now I'm within this bash, and within this bash, I have access to this SSH agent. With this access, I can do two things. First thing, I can give the SSH agent a key. SSH -add is a tool to give my key to the agent, and while giving the key to the agent, I decrypt it by a passphrase. So now my SSH agent knows this identity. So first, I can give a key to the SSH agent. Second, I can use this SSH agent for giving the key to the SSH client. So the SSH client sees with environment variables that there is an SSH agent in place and asks this SSH agent for the private key. Yeah. And now I can connect. I can connect to the remote system without entering a passphrase, but my private key on the disk is still encrypted with a passphrase. And I can do this as often as I want to. Yeah, as long as I don't terminate the bash that was started via the SSH agent. Yeah, the SSH agent starts a bash. From this bash, I'm working here from here on, and in this bash, I have access to this SSH agent. Yeah, we can give via SSH add a key to the SSH agent. The SSH client tool asks the agent for the key. Yeah, let's have a look. Grab SSH agent. What you see is here is one SSH agent running, and there are some environment variables set within the current shell so that all my tools, SSH add, SSH client, and there are some other tools that these tools have access via this socket to this SSH agent. Yeah, and I can use the key again, yeah, as long as I don't leave this bash. If I leave this bash that was started from the SSH agent or by the SSH agent, here, exit, then I need again the passphrase. And most distributions, most Linux distributions have implemented an SSH agent for running every time in the background. So if you use on these distributions, if you have a distribution, a Linux distribution on your desktop, and you use there an encrypted key, yeah, for public key authentication, then you only need the first time you start the SSH connection to enter the passphrase, and then this key will be given to the SSH agent, and the second time, the third time, and so on. You can connect without entering again a passphrase. And then if you log off from the system, if you leave your session, then the SSH agent will be terminated and your password or your passphrase, your private key will be forgotten. Yeah. So this is the way the private key authentication works. Yeah. Once again, we have SSH key gain to generate a key pair that is stored on a default location. Then we transfer this to a remote system. How can we transfer this to a remote system, this public key? Via the tool SSH copy ID. Yeah, we transfer this public key to this authorized keys on the other side. Yeah, and then we can simply use SSH for connecting to the remote system. Yeah, and we have here the SSH agent. We can start in multiple different ways. Yeah, the most easiest way I showed you here is SSH agent and a bash as a child process of this SSH agent. And then we use the tool SSH add to add our identity file, to add our private key to the knowledge base, yeah, of the SSH agent, so that the SSH client next time can ask your running SSH agent to give it the encrypted or decrypted private key to prove the authorization or to help to prove the authorization challenge. Yeah. Okay. I hope that was understandable. I hope you enjoyed this lesson. See you next time.